This video is going to be about heat engines. We're going to look at heat engines by looking at a piston that sits within a chamber. So this is my piston, and this piston is going to be able to do work by lifting this block of mass M. Underneath the piston, there's a gas trapped. I'm going to add heat to my gas, causing the gas to expand, and as the gas expands, it's going to do work by pushing the piston and the block upwards. This is going to be an important thing you guys need to remember, that anytime the gas expands, the gas is doing work. Now that my piston has done work, it needs to be restored back to its original position so that it can do work again. Otherwise the heat engine would be over. So I'm going to take the block off of my piston, and I'm going to lock the piston in place and allow the gas inside the piston to cool down to its original temperature without changing its volume. So this is isovolumetric. Last, I'm going to remove the pin and apply an external force to compress the gas. So now I'm doing work on the gas, which causes heat to leave my piston and enter the surroundings. And this restores the piston and the gas to its original configuration where we started in step 1. Because the heat engine works on an exchange of heat going from a heat reservoir basically to a cold reservoir, we can think of a heat engine kind of like this diagram. The heat engine takes heat from a hotter reservoir into the system and uses that heat energy to do work. At the end of the cycle, heat energy is pushed out of the system from the warmer system to a cooler reservoir to finish the cycle. When the heat energy is entering the system to do the work, the gas is in an expansion phase. And when it's being restored to its original place and being pushed out into the surroundings, the heat engine is compressing the gas. Interestingly, if you look at how a refrigerator works, it's doing the opposite of a heat engine. Work is being done on the gas in order to move heat from the cold reservoir, which would be inside your refrigerator, to the warmer surroundings, which would be outside your refrigerator. Alright, that's the end.